வணக்கம். Welcome to this course on classics in neuroscience. We have been looking at the first set of videos on why do we study history and why do we want to focus on the 1940s and the 1950s. In this video, we will be discussing the factors that produce grand discoveries. What is the purpose of this course and this study of history of classics? What is the purpose? It is not merely to recount the chronological order in which discoveries happened. It is useful to know the chronological order in which discoveries happened, but that is not the purpose of this course or studying history in general. The purpose is to learn something from history. The purpose is to understand the critical factors that led to the development of a grand discovery. And once you study these factors, you realize many of these factors will have to happen simultaneously, or there has to be a confluence of factors for grand discoveries to happen. What are these factors? Like I mentioned, we are interested in the creative process. We are interested in the process that led to the discovery, not merely recounting what happened when, because that would be a mere chronological listing of, okay, in this year this person found that, in X year Y found Z type of listing. That can be found in Wikipedia, for example. That is not a very useful endeavor. We are interested in the thought process. What went behind the scenes? What was the thought process? What was the interpretation, scientific thought process behind this? What are the factors that produce the great leaps forward in science in general and in neuroscience in particular? It turns out that there are 6 critical factors that lead to a grand leap in discovery. These are methodology, the preparation, the PI or the investigator, the conceptual framework or the theoretical framework, chance and support. We will discuss these one by one. We will take each one of this and I will discuss each one of this in some detail. First is methodology. As an experimentalist, I am always interested and obsessed with methodology. For young investigators and research scholars, methodology essentially refers to having access to the latest, hottest, newest equipment, having this new toy. This is what it means. As the saying goes, methodology is not everything, it is the only thing. Methodology is not everything, but rather it is the only thing, is what the saying says. Is that true? Is it the only thing? What we have found is, what we find from history is actually the opposite, as substantiated by Alan Hodgkin's view on having equipment. This is what he says. Nowadays, it is regarded as somewhat unscientific to carry out experiments with anything but the best equipment. This certainly wasn't my feeling when I started research. All that mattered was that one should have enough equipment to do something new. The example from physics at the Cavendish was that it was an elegant piece of apparatus or an elegant experiment meant one that could be built or carried out very cheaply or relatively frugally. So, what Hodgkin says is that it is not necessary to have the latest equipment to do the best research, but rather to answer a specific question you need to have the best possible, or the question that will just answer. To answer the question that is being asked, you want to have the equipment that will just be enough but not more. The most frugal or the most inexpensive experimental apparatus that can answer the question is the best experimental apparatus. So, it is your research question and your theoretical or conceptual framework that must drive your research, not the equipment that you have, not the toys that you have. You do not design experiments around a toy, but rather you have a question and then you find equipment that can best answer your question, even if it is inexpensive. Sometimes it may require an expensive equipment, but an expensive equipment alone will not do the best possible research, because research is done in our head. It is done by us, not by the equipment. Equipments are tools, right? So, this is what Hodgkin says. This is my view, or this is my commentary on what Hodgkin says. So, the best possible equipment is one that can answer the question, but can also be as inexpensive as possible, but not more. So, for the study of neuroscience, technology, latest developments in engineering or computational analysis, computer science are critical, are very useful. They inform us, but it is not everything, or not only is it not the only thing, it is also not everything, because it depends on many other components. The second factor that goes into enabling the grand leap in the field of neuroscience is the biological preparation. It is important to find a model system. It is critical to find a model system that will just enable answering the question that is posed using the technology that is available. The smart matching of the technology or the methodology with the biological model system is what has led to the development of some of the discoveries in the field of neuroscience. For example, in the case of Hodgkin and Huxley, this was the giant squid axon and the measurement using the technique that they developed. So, this smart matching, when it happens, you are going to have that grand discovery, you are going to have that one great leap further in the field of neuroscience. So, it is important again to not be obsessed with one biological preparation over others. It is important to choose your biological preparation such that it is just enough to answer the question that you are posing, as in the case of methodology. The third factor is the principal investigator or the investigator. The investigator must bring in their own unique set of skills, but also it is expected that the investigator go on to learn from other investigators. Hodgkin's recollection of the lessons he learned from his collaborators, for example, provides a unique example and a unique perspective of how your ability to interact with your peers and learn from them and inform them to a large extent influences the possibility or the probability that you will produce a grand discovery or a great leap. So, for example, Hodgkin brought in his education, how his early education led to the development of this technology and the questions that he asked, and his interaction with other colleagues also led to the development of this finding. Again, the next factor is the choice of theoretical framework or a conceptual framework. There is a statement by theoretical physicists: you cannot explain a fact without a theory. This is a statement that is contested by others, but at least it is accepted within the field of theoretical physics. As an experimentalist, I am excited whenever a student brings in a new line of experimentation, a new idea to experiment. Often there is a tendency or a temptation to prioritize experiments over theory. Always remember, theory precedes experimentation. You need to decide the theoretical framework within which you will perform the experiments, or the hypothesis, the questions that you will be asking must be prioritized over and above the experiments that you will be performing. The reverse cannot be done or should not be done. Or in other words, you cannot perform an experiment, have some results, and then think about which theory fits this best, because that would not, or that is less likely to lead to the grand leap in discovery. So, theory precedes experimentation, and something that we need to prioritize, continue to learn, and always emphasize to our students is that theory precedes experiments, and your choice of theory, your experimental question or your theoretical question and your hypothesis precedes the experimental approach that you will take. Although as an experimentalist, I am obsessed, I love when a student brings an experiment, I am like, oh yeah, let's do this experiment. But what is the question? What is the theory that we are testing? This should always be the question I must ask my students when they bring in, or when I bring a question, the student must ask me. When I bring an experiment and say, hey, let's perform this experiment, it is expected the student will ask me, okay, fine, what is the theory? Because theory precedes experimentation, and it is important to have this conceptual framework. Again, going back to the example from Hodgkin and Huxley, they tested several theories before coming up with their final theory, that they then tested with experiments. They tested several theories and discarded many of them. So science is this process in which you keep repeating, you keep iterating, discarding the wrong theories, because it is not possible for you to find the right theory. You can only discard not correct or incorrect theories. This will eventually lead you to finding of the right theory or the correct theory. Because science is like this, it takes a long time and many iterations and many experiments to find the correct theory. This is tedious process, and this is what makes science exciting. This is why we need to perform science in this way, because it gives us that joy of discovery, having failed. Many times when you have that moment of discovery, when you are having that meditative moment, when you find something, that's what this means. That moment is hard to come by. It happens once in 100 times or once out of 10 times of trials. So those inspiring moments are the moments why we do science, right? Then the next factor is the factor of chance, or the probabilistic nature of our existence when we perform experiments or test theories. It is important to recognize the role chance plays in our ability to make these grand discoveries. You need to be at the right place at the right time. You need to be performing the right questions. You need to be testing the right questions using the right experimental approaches. You cannot improve your chance by merely wishing for it, but you can prepare. Like Louis Pasteur said, that this chance or the luck, as normal people would call it, as the common people would call it, luck, it favors the prepared mind. So you can increase the probability that you will be successful, but you cannot maximize it to 1. You cannot maximize the chance that you will discover something, or you cannot make sure that you will discover some grand thing. That is not possible, but you can maximize by preparing yourself well. So, there is always a chance that you will succeed, also a chance that you may not succeed despite trying very hard, despite having many things together. This means that you will have to keep on trying even after failures. This is something that students and even faculty members do not recognize, that you need to keep on trying. If you fail once, keep trying a different experiment, keep trying a different theory, keep testing other theories. At some point you will find. So, it is important to recognize the role of chance in your journey of discovery. Then most importantly, nowadays, the role of support. When I say support, there are many forms of support for an investigator for this to happen. The book discusses the financial support, which is true for performing modern neuroscience. You need an extraordinary amount of financial support these days. But I would also speak about, first is financial support, okay. The second is institutional support. You need to be in the correct institute or the correct university or the correct system to do the studies that you want to do. This is critical, because your studies and your experiments and your research to a large extent are influenced by where you are performing these studies. So, institutional support becomes critical. Of course, for an investigator, family support and student support, student or collaborator support. Students are collaborators, student collaborator support. All of this are important, are crucial in the development of the grand discovery or in your journey towards the grand discovery. So, there are these 6 factors: methodology, preparation, the biological preparation, principal investigator or investigator, theoretical framework or the conceptual framework, chance or probability, support in its various forms, that is financial support, institutional support, family support, support from students and collaborators. All of this should happen simultaneously, or in other words, you need to have confluence of all these 6 factors. All these things need to work together, and on top of this, the investigator must also work towards a grand leap. Only then it is possible for the investigator to make that great leap in the field of neuroscience. With this, we come to the end of this video. In this video, we saw the various factors that lead to the development of great discoveries or grand leaps in the field of neuroscience. Thank you very much for your attention.